AI and machine learning applications have become an important driver of CPU and network usage. Businesses are deriving large value from these applications, and we see AI clusters growing substantially over the coming years. One common characteristic of these workloads is that they're compute and data intensive. They often involve a sparse matrix computation so large that the parameters have to be distributed across hundreds or even thousands of processors. Each processor computes intensely for a period of time and then shares its results with the others in a burst. Each then merges its peers' data with the local data, and another round of computation begins. The volume of data exchanged in this cycle is huge. A slowdown in the network can severely impact the runtime. Moreover, our customers are saying that the network's importance is growing as the problem sizes get larger. The upshot? Wire rate delivery of large, synchronized bursts of megabytes to gigabytes even is essential to application performance. Historically, these problems were the domain of special-purpose networks like InfiniBand, but the rise of Ethernet NICs with RDMA and Rocky has enabled an IP Ethernet transport fabric without sacrificing performance. Now, the advantages of Ethernet and its economies of scale for these problems is huge. The industry is churning out CPUs, GPUs, and TPUs with tons of parallel cores, special matrix instructions, memory, I/O, network speeds to match. Moore's law and the path from 7 to 5 to 3 nanometer silicon for networking is clear, and Arista is riding that wave from 100 to 400 to 800 gigabits per second. The ideal network for these applications is a lossless fabric that can interconnect hundreds or thousands of processors at wire speed. On top of that, to support AI and ML, Arista's EOS operating system provides critical network functions: flexible load balancing for elephant flows, priority flow control and ECN marking to support RDMA, QoS to prioritize latency-sensitive control packets, and advanced monitoring of latency, PFC, and drops. EOS has features like PFC watchdog, PFC counters, LANs, and drop mirroring to support these applications. Of course, every Arista AI network leverages the flexibility, debuggability, and simplicity of a standards-based Ethernet fabric. We have customers successfully using an AI leaf-spine network with 7060s talking to RDMA host NICs. But for the best performance and scale, Arista has the 7800 as the premier AI interconnect. The 7800 has the following strengths: hotspot-free internal load balancing, internally congestion-free PFC to ensure lossless delivery, exceptional flexibility for buffer tuning, a single chassis that can connect 576 GPUs at 400 gigabits per second, and it's got industry-beating power per gigabit, and we're seeing power increasingly important in these networks. No matter what your application, Arista has the best AI-optimized interconnect in the 7060 and 7800 series. We look forward to partnering with you to bring the advantages of merchant silicon, Ethernet, IP, and EOS to your network. Now, I'd like to hand off to Pradeep and Narayanan, who've been working closely with customers in this space, to report on what they are seeing directly. Take it away, guys.
That's very insightful, Hugh. What do you think, Pradeep?
Hey, Narayanan. This is a very interesting topic. Thanks to artificial intelligence and machine learning, the amount of data being processed today has dramatically increased. We've helped large public cloud providers design and build dedicated AI fabrics, which, by the way, is quite possibly the largest deployment of RDMA over Converged Ethernet, also called Rocky, in the world, and it's being leveraged by their customers to target use cases like deep learning, data analytics, scientific simulations, and autonomous driving. How about your customers?
I support large web and cloud customers, and for them, they need to deliver better experience for end users. It really means deliver better ads, better feeds on social media, deliver better gaming experience, and all things metaverse. To achieve this, there is a need to integrate all the information available, analyze them seamlessly, run through their training clusters, and then use the resulting insights to generate better results. Very similar to what you are seeing with your customers.
So Narayanan, how are they building these networks? Do you see InfiniBand being used?
For the last decade, we've been helping our customers build large data center cloud networks with IP Ethernet switches in a leaf-spine topology. My customers have been able to scale them to tens of thousands of racks. However, for AI/ML clusters driven by GPUs or DPUs, they have special needs. Historically, InfiniBand was considered, but with the success the customers have had with Ethernet, they want to replicate the same for GPUs. They want to standardize on Ethernet irrespective of their workloads. What about your customers?
InfiniBand does not scale well in the cloud and was not designed with multi-tenancy in mind. Operating a cloud-scale InfiniBand network is something that my customers do not want to sign up for.
But these workloads are RDMA based, and InfiniBand was known for RDMA.
They are. These AI ML clusters require a lossless, low latency, high bandwidth network, and believe me, EOS handles this exceptionally well with support for data center quantized congestion notification, also known as DCQCN.
So how does Arista make this happen with Ethernet?
Glad you asked. This is exactly where EOS shines and brings great value to our customers. What EOS does is, it takes into account the changes in real-time utilization of network links and rebalances traffic across them. This helps achieve even utilization at all times, the end result being higher aggregate throughput and shorter completion times for the ML workloads. So that's about EOS. Can you shed some light on what's the most popular platform of choice for these applications and why that is?
Absolutely. My customers have small AI clusters that fit into a single 7800, and some AI clusters span across hundreds of racks. That means thousands of GPUs. For mega-scale clusters, a combination of leaf and spine is a fantastic solution. In either case, the 7800 plays a very critical role. 7800 delivers cell-based BOQ architecture, has great load balancing and packet spraying capabilities, supports a wide range of radix and port speeds ranging from 100 to 400 gig, and finally delivers the best low power performance in the industry. And 7800 is 800 gig ready. All things Hugh said apply very well to my customers and other large enterprises. The strong combination of Arista platforms and rich EOS capabilities is the best solution to build GPU clusters driving AI/ML applications.
For more information on the Arista 7800 AI Spine, visit us at arista.com.